Probability distributions are really useful. We can use them to calculate the typical values for something where numbers have a lot of different values. So for instance, we can use them in quantum mechanics. The wave function squared is essentially a probability distribution. We can use them to calculate the average speed of gas molecules. We know that if we look at a gas sample, the molecules are flying around with a bunch of different speeds, and we can show what the probability for each speed is with a probability distribution. So let's look at a very simple probability distribution and just do a simple case study, and then we'll use the skills that we gain from that to look at more complicated probability distributions. So let's start with a probability distribution where you've got Spider-Man locked out of his treehouse. So we've got the treehouse here, and here's the treehouse, and he should be able to get in, but he's locked out, so he's stuck outside. So let's imagine that the treehouse has a radius r0, and whatever Spider-Man's distance from the center is, we're going to call that r. Okay, so since he's locked out, there's a constraint that r must be greater than or equal to r0, because he can't get inside the treehouse because he's locked out. And we know that he can fly above the treehouse and below the treehouse and around the treehouse, but he can't get in. And in fact, he might have an excursion where he goes off and gets something to eat, or gets frustrated and he goes to see a movie, but he can't. He's eventually going to return and try to get back in, so he's going to be buzzing around here, but he can't get in. So most of his time he's going to be near there. So the probability distribution for this situation might be represented by something like k r to the -5th, where k is some constant. We don't know what it is yet. We'll figure that out later. And we can see if we have a function like this that the further away we get, the lower the probability there is, that's what this is, of finding Spider-Man there. So if r is a big number, there's a low probability of finding him at that location. And if r is a small number, it's going to be this probability is much bigger, but there's a constraint that we can't go lower than r0. As we increase the value of r, this is going to die off more quickly. So we can put something like, it's going to look something like this. So it's some sort of decaying thing that decays to 0 as we go to, because remember this is just going to be equivalent to k over r to the 5th, right? So the bigger the r is, the smaller this probability is. Okay, and so we have some sort of probability function that looks like this. Okay, so it's very high next to the treehouse, and then it dies off. So that's what our probability distribution is. So two things we can do with the probability distribution is we can use boundary conditions to find a numerical value for constants like this, and we'll do that in the next screencast. And the other thing we can do is use them to calculate the average value. So we know that at any given time, Spider-Man might be at any distance, r, but if we averaged it out, what was his average distance going to be? And we can calculate that using a probability distribution too.